All right, guys, hope you're doing well. Someone in one of my classes requested an overview of kind of everything we've gone over so far in Unit 1 and what the important things are. So there's a few different types of questions that you'll need to be able to do, and let's go through these. Now, as I write the questions down, I'd encourage you to pause the video for a minute, give it a go on your own, and then check and see if I'm getting the same answer that you are. All right, let's start with these kinds of questions. So we have 4x parentheses 3x minus 2. Now this is a distributive property question, and so we're thinking that's going to hit this guy, and that's going to hit this guy. So we have 4x that's going to hit 3x, so 4x times 3x, and we also have 4x hitting the 2. Now we've got to think about what the sign is in between. That negative sign is going to come down there. All right, so 4x times 3x, that's going to be 12. 4 times 3 is 12x, and another x is going to give me x squared. Now right here we have 4 times 2 is going to give me 8, and we have x, and now you're all done. Now you can also think of this same question as an area problem. If I've got a box here that's 4x tall and 3x minus 2 wide, I can find the area of each of these things. 4 times 3 is 12x squared, and then this box is 4x tall, negative 2 wide, that's going to be negative 8x. And you get the same answer here as you do here, 12x squared minus 8x. Now thinking of things as an area problem is helpful for these types of questions, where we have 5x minus 1 parentheses 3x plus 2. Let's do this using what I am going to be calling the box method. So here we have 5x, here we have minus 1, here we have 3x, here we have 2. Now we're going to multiply these together. So we're going to multiply 5x times 3x. Now 5 times 3 is 15, x times x is x squared. So this is 15x squared. Now the next thing is we're going to multiply these guys together. So 3x times negative 1 is negative 3x. Now we're going to multiply, let's change colors here. We're going to multiply this one and this one together. 5x times 2 is going to give me 10x. And finally, we're going to multiply this one and this one together. And if we multiply these together, then 2 times negative 1 is negative 2. So let's go ahead and write this out. We've got a 15x squared. We've got a negative 3x. We have a 10x. And we have a negative 2. So this is almost done. We're almost able to be done here, but we've got to combine some like terms. The x squared is a different kind of animal than x's, and so we can't combine these together. But if I have these ones together and these ones together, then these are both x's. They're the same terms. So we can combine those together, and let's go ahead and do that. 15x squared, negative 3x plus 10x. That's the same thing as 10x minus 3x. That's going to give us 7x minus 2. So we've got 15x squared plus 7x minus 2. Now let's do this one. I want you to try this one on your own. So pause the video, give that one a try. Okay, now let's go through and do this one. So we have 3x, negative 1, 5x, and 2. 5x times 3x is 15x squared. 5x times negative 1, negative 5x. This is 6x, this is negative 2. So writing this out, 15x squared minus 5x plus 6x minus 2. And combining my like terms, I have 15x squared plus x minus 2. Hopefully that's what you got. If not, then you can do some more similar questions like this in the unit review test that we have. Okay, let's do another one like this. Let's say we have 4x parentheses 2x minus 1 and then minus 2. And the prompt for this question will be something like multiply out and combine like terms, something like that. So the first step is distributive property. And so let's use the distributive property to get those numbers out. 4x times 2x is going to give us 8x squared. 4x times negative 1 is going to give us a minus 4x. So that one's pretty simple. Now we've got to distribute this. So when we distribute this, what are we distributing? Are we distributing the 2 or are we distributing the negative 2? Here, the best way of looking at this is distributing this negative 2. So it's the negative 2 that's going to hit both of these terms. So let's do that. Negative 2 times negative 2x is going to be negative 4x. Negative 2 times negative 1 is going to give me a positive 2. Now I'm looking at this and looking at my like terms. These guys are like terms. We can combine them. I've got 8x squared minus 8x plus 2. Okay, I want you to give this question a try. So go ahead and pause the video, give it a try. Okay, let's do this. So that's going to give us 6x squared. That's going to give us 3x. This is going to give us a negative 20x. This is going to give us a negative 4. So now combining like terms, we have 6x squared minus 17x minus 4. Okay, let's go on. Let's talk about the slope of a line that goes through 2 points. So let's call this point 2, 4, and this point we're going to call 3, 7. So recall that slope is rise over run. So I want to look at how much I rise between these 2 points. So how much you rise is the difference in how high you are. So here, how high is that point? How high is this point? Well, looking at these coordinates, which one gives you information about the height? It's actually going to be the second one. So when you're finding the slope, you're focusing first on these second coordinates. So for the rise, it's going to be 7 minus 4. And now what about the run? The run is going to be the difference between 2 and 3. So we're going to do 3 minus 2. 7 minus 4 is 3. 3 minus 2 is 1. 3 divided by 1 is 3. So here, the slope is 3. Now the last thing I do is I just check, is the slope going to be positive or negative? And if I go up as I move to the right, the slope is going to be positive, so our answer here is just 3. Let's do this one. Find the slope between negative 4, 5, and 1, 4. Go ahead and pause the video, find the slope between those lines. Okay, let's look at these on a graph. So the first point, negative 4, 5, is going to look like that. This point is 1, 4, and so x is 1, y is 4. Obviously, these aren't drawn to scale, but they'll be good enough for what we're doing. Okay, so again, slope is rise over run. And the thing that talks about the rise, the thing that we care about first, is this one right here. So we're going to do 5 minus 4. Oh, running out of room there. Let's do 5 minus 4. And on the bottom, we're going to do negative 4 and 1. So let's do negative 4 minus 1. That's going to give us 1 over negative 5, negative 1/5. That's going to be our answer. And just check and make sure, does negative make sense? Are we going downhill as we go from left to right? And we are. We're not really rising 1. We're more like we're falling 1. We're going down 1 from 5 down to 4. And we're going over 5 from negative 4 to 0, then over to 1. So that's a total of 5. So our slope is negative 1/5. Okay, let's talk about things like this where we need to find the range and all that good stuff, domain. So let's say I've got something like this, and let's have an open circle there. And let's put in some grid thing like that. And let's have this, let me erase this. We'll have this blue line go all the way down there. Okay, so domain. The domain is the difference, or it's how far left and how far right we go. So for the domain, we only care about x values. So for my x values, I'm just going to make up the number here. Let's call that -4, and it's going to go all the way here to 7. So for the domain, I'm going to write -4, 7. The next judgment we need to make is whether we do square or rounded brackets. If you see something filled in like this, it's a square bracket. If you see something like this, it's a rounded bracket. So here we're going to do a square bracket to reflect that it actually goes to -4. And we're going to do a rounded bracket to show that it doesn't quite actually reach the 7. So that's the domain. Okay, now let's talk about the range. The range is how far up and how far down we go. So looking at this, the only thing we care about are the y values. So I'm just going to erase these x values because we don't really even need to think about them right now. And now the y values. Well, you can see pretty clearly this guy right here, this is down at 0. So it gets all the way to 0. And this point, let's say this is 4, and let's say this one is up here at 10. So the range, the lowest we get is 0. What's the highest we get? Well, if I'm here, I'm going up higher. I get up to 4, but is 4 the highest I get? No, it's not. I actually go all the way up here to 10, so the range is 0, 10. Now, on the bottom, we got to think about what kind of things. Do we use these or do we use these? And because it doesn't include 0, we're going to do that. That means the lowest it gets is something like 0.0000001, but it never actually touches 0. And in terms of how high we go all the way up to 10, and we actually will reach 10. So this roller coaster will actually get up to 10, and it'll go down there. So we include that bracket. So the range is parentheses 0, 10 square bracket. Okay, let me do another one, and you guys try this one on your own. Okay, that should be everything you need to know on this guy. Go ahead and write your domain and your range. Pause the video and give it a go. All right, so our domain here is going to be everything. I don't know why I wrote a -2. This is a 2. Our domain is going to be everything from 2 all the way to infinity, because there's no limit to how far my x values can go forward. And we will include the 2, but we never get to infinity, so we do a rounded bracket. Now for the range. The first thing you write, guys, this is really important, is the lowest value. So the lowest value here, we start as low as possible. And I think, is there any limit to how low I can go? And no, there's no limit. I can go super, super low, right? Like stealing candy from a baby low, right? So the lowest I can get is -infinity, and I just made a mistake. I don't actually get to -infinity. I'm going to do a rounded bracket here. Now, what's the highest I get? So imagine I am a little bug riding this little roller coaster. I'm getting up to here. I'm getting higher and higher. The highest I get is up to that 8. So we do 8, and I will, in fact, reach the 8. So my domain is that, range is that, and hopefully you got the same thing. Okay, let's go now and talk about, let's look at the example I just did and think about it a bit more. Let's think about whether this is a function. So a function is a situation where every single x value just gives you one y value. Now here, let's just imagine this x value of 3. If I plug 3 into my little machine here, then my machine is going to give me, let's call this guy 4, and let's call this guy 8. So I have the point 3 comma 8, or sorry, 3 comma 4, and I have the point 3 comma 8. Well, that's the kind of situation where 3 goes in the machine, it gives me a 4, 3 goes in, it gives me an 8. So one input is giving me 2 different outputs. So this would not be a function. And you can tell it's not a function because the x values repeat. X values repeat means no function. And if the x values don't repeat, then you are going to have a function. So by repeat, I mean we have the point 3 comma 4, we have the point 3 comma 8, and this x value has repeated itself, so that's not going to be a function. Okay, next one. So this function or not a function, it's going to be a function because it satisfies the vertical line test. The x values don't repeat, and so that's good. Let's just practice another important skill here. Let's call this guy 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And let's just label this 1, 2, 3, 4. Okay, so let's practice these kinds of questions where it says f of 2. So when it says f of 2, it means find the y value for when x is 2. So you're just going to go up here, and then you go, so f of 2 is equal to 2. Let's do a different one. Let's do f of 3. So this one, we're going to go, and then f of 3 is 0. Let's do this one. Let's do f of 4. What's f of 4? You got f of 4 is 0. What about f of 5? You go, and then and f of 5 is equal to 3. What about f of 6? And then you got 4. Okay, so that's how those kinds of things work. Let's do the same kind of question now, but in a table. And we'll call y f of x. But we can use those interchangeably. So what is f of 2? Well, f of 2 is going to be 11. So this is f of 0. This is f of 1, f of 2, f of 3. F of 3 is 13. Okay. What else do we got? Okay, this is another important thing here, plugging things into quadratic equations. So let's say I have some function. Let's call this f of w, just to mix the letters up. And let's say I have 6w squared minus 3w plus 2. And I'm going to do f of negative 2. What that means is in this equation, wherever I see w, I'm going to replace it with negative 2. Everything else stays exactly the same. So that minus sign comes down, the 3 comes down, but here instead of the w, we're doing negative 2. But then the plus comes down, the 2 comes down. So everything is exactly identical except for the negative 2. All right, what's negative 2 squared? Let's just do this question right here as a little sidebar. Make sure we understand it. Let's do a little sidebar here. So what's negative 2 squared? Negative 2 squared means I've got negative 2 times negative 2, and negative times a negative is a positive, so that's going to give me a 4. So where I see this, I'm going to write a 4 there. So we're going to do 6, and I'm going to put the 4 in parentheses so it doesn't look like 64. That would be confusing. And now let's just write everything else the same. Don't be afraid, guys, to write a lot of steps on these and just do one little thing during each step. 6 times 4 is 24. Right here, let's think of this as a -3 times a -2. -3 times a -2 is going to give me a +6. 24 plus 6 is 30. 30 plus 2 is 32. So break it down one little step at a time. It should kind of funnel down to give you the right answer at the bottom. Okay, this one I want you guys to do on your own. Pause the video and give this a try. If f of x is equal to 3x squared minus 2x plus 1, what is f of -4 going to be? Pause the video, give it a try. Okay, you're back. We got 3, plugging in a -4. So -4 squared is going to be -4 times -4. That's going to be a 16. So replacing this with a 16, I have 3, 16, -2, -4, plus 1. 16 times 3 is 48. Here I have a -2 times a -4, which is going to give me a +8 plus 1, and then you can solve it out from there. Cool. All right, other kind of question, I think we got 2 or 3 more. Let's say we've got something like this. 6x to the 4th plus 9x squared minus 15x to the 11th. All right, let's think about what these are if we break them down into their pieces. 6x is the same thing as 3 times 2. 6x to the 4th, we got 4 x's. 1, 2, 3, 4. Let's break apart 9x squared. So that's 3 times 3x times x. Let's break apart 15. That's 3 times 5. X to the 11th is 1, 2, 3, 11 x's. So what do all of these things have in common? Well, they all have a 3 in common. So let's write that there. They all have an x in common. And they all have another x in common. So our common factor for these is 3x squared. And that's all you got to do. Let's do this one. Pause the video, give this one a shot on your own. Let's do 5x to the 9th plus 15x to the 5th plus 10x to the 3rd. All right, so looking at the numbers, 5, 15, 10, their greatest common factor is 5. These guys, I can take 3 x's out of both of these. So I'm taking the most number of x's I can out of all of them. The most I can take is 3, and that's it. Okay, let's look at something like this. These ones are not too bad once you know what you're looking at. And let's just put another 6 in there. Okay, so this kind of question, let's talk about the domain, the range, and whether or not it's a function. So the domain are all the x values. So let's just write that out. We're going to do these kind of fancy brackets, and 2, 6, -5, 9, 6. Now, that's good in the sense that we got all the x values, but the one thing we have to remember is that we can't have any repeats. So no repeats. No repeats. So let's go and look and see if we have any repeats. 2, and then aha, this is my repeater. So we've got to get it out, erase the 6, erase the comma. Now we have the right answer, and we're happy. Okay, for the range is just all the y values. So here we're looking at all of the y values. And I've got a 1, I've got a 5, I've got a 4, I've got 11, I've got a 7. I have no repeaters, so we're good. Now the question is whether or not it's a function. So for a function, we're looking at, do any x values repeat? And if the answer is yes, then we say no, it's not a function. The reason why it's no is because, let's just highlight these, and this one, that means if I have my machine and I plug a 6 into it, then my machine spits out a 5 and it spits out a 7, and it's a really confusing machine. And if I were to graph it, then I'd have the point 6, 5, 6, 7, which would violate my vertical line test. So not a function if the x values repeat. Okay, we're almost done, guys. Just 2 more types of questions. These questions are when you're trying to turn a linear pattern into some kind of function. Let's call this 17, 14, 11, 8, and 5. So the question, the prompt here is to, first of all, determine whether it's linear, exponential, or quadratic. Now, I always try first to see if it's linear. If it's linear, it has some kind of common difference. So going from 17 to 14, 14, 11, I'm noticing that each time I'm going down by 3. So yeah, it's going to be linear. Now, if it's linear, explicit equations for linear always look like this. Y equals mx plus b. What does the m stand for? The m stands for the slope, which will always be your common difference. So here, my common difference is -3. So we're going to rewrite this equation as y equals -3x plus, now I've got to talk about the b. The b is the y-intercept. Now, the y-intercept, if I look at a graph right here, and this line cuts through the y-intercept, the coordinates of that point are going to be 0, something. So the y-intercept is always when the x value is 0. So the y-intercept is when x equals 0. But now looking at my table, I actually don't have x equals 0 on there. So I've got to add it. Let's add it up here, and let's figure out what that would be. So if I am minusing 3 going down that direction, then I'm plusing 3 going up this direction. So 5 plus 3 is 8, 8 plus 3 is 11, plus 3 is 14, plus 3 is 17, plus 3 is 20. So my y-intercept here is going to be 20. Now, you shouldn't just stop here. You should always plug in some numbers and see if they work. I'm just going to randomly pick the number 4. And we're going to plug that 4 in place of this. Let's plug this guy in. And -3 times 4 is -12. -12 plus 20 is 8. And I get the output that I want. So if 4 is my input, 8 is my output, and that's working. So it passes my test and we're good to go. Okay, next thing we need to do here is to find the recursive equation. So there's got to be a better way to erase all of this. But we'll just try this kind of messy thing. Okay, so recursive equation always look like this. No matter what you're doing, recursives always start with f of x is equal to f of x minus 1. Now what it's saying is to find the next y value, remember f of x is a y value, to find the next y value, I do something to my previous y value. Now if I was to find the next value here, I would just be subtracting 3 from 5 and I would get 2. How did I get 2? I did 5 minus 3. I'm just subtracting 3. So that's what we say in a recursive formula. Let's write this out as an example. This is 6. I wanted to find f of 6. This guy right here, this thing is f. The y value is f of 6. So I took f of 5 and I subtracted 3 from it. Now if I want to find the next y value down the line here, f of 7, then I'm going to take f of 6 and I'm going to subtract 3 from it. And it just iterates over and over and over again. Okay, now we're going to do the same kind of thing here, but with a exponential pattern. So x, y, 1, 2, 3, 4. Let's go for 12, 24, 48, 96. So first of all, how do you tell if it's exponential? Well, try linear, adding 12, adding 12. Hang on a second. If we add 12, it doesn't work. So it doesn't work if it's linear, which I always try. And so let's try timesing by something. And so if we're timesing by something here, timesing by 2, timesing by 2, timesing by 2, that's working out. Okay, now anything exponential is always in the form y equals k times a to the x. Now let's think about what these things stand for. K stands for your y-intercept, which again, in our example right here, it is the y value when x is equal to 0. So the intercept, the y-intercept is the y value when x is 0. So y-intercept, and then the a is going to stand for your common ratio. So looking at this, we already have a common ratio, and it is 2. So we can write y equals something times 2 to the x. Now, what is our y-intercept? We got to walk this table backwards like we did before. 4, 3, 2, 1, 0. And 96, 48, 24, 12, dividing by 2 going backwards, 6. And so if I'm looking at this, I've got the point 0, 6, so 6, and my final answer is y equals 6 times 2 to the x, but don't relax too much. Let's plug a number in and see what happens. Let's just pick 2 at random. We're going to plug a 2 into here, and if I do that, then I get 2 to the second, which is 4. 6 times 4 is 24, and that's what I got. So 2 as an input gives me 24 as an output. Okay, now let's talk about recursive. I'm just going to make a new thing here. 1, 2, 3, 4, and we've got 12, 24, 48, 96. Now, if I want to find, let's just call this f of 1, this is f of 2, this is f of 3, this is f of 4. If I want to find f of 5, how am I going to do that? Well, like we did before, we're just timesing by 2, timesing by 2. So to find the next one, we're timesing by 2. So if I wanted to find out what f of 5 was, then I would take this value, which is f of 4, and I would times it by 2. Now, just broadening that a little bit, if I want to find f of x, then I'm going to do the y value before that, and I'm going to double it. And that's our recursive formula. Oh, and recursives always need to start somewhere, so we'll say f of 1 equals 12. And this whole jumble of things, that's going to be your recursive formula. Okay, guys, I know this was a lot, but this covers literally every type of question you're going to see on the test and the main things that we want to remember for the course. As always, if you've got questions, send me an email or a message in Canvas.